So when we were looking at solving quadratic inequalities before, you might have been asking yourself, well, why didn't we just graph these and look at them to see where it's above the x-axis and below the x-axis? Well, it turns out it works well with quadratics, especially when they factor nicely, and we can graph them pretty easily. However, the same techniques that we use for the quadratics, it turns out we can use for more complicated functions or complicated expressions. So particularly if I had a polynomial that was bigger that could still be factored, then I could still use those same techniques. Or another type of expression that we can use that technique on are what are called rational expressions. Okay? Or particularly we're going to look at rational inequalities. A rational expression is basically any time that you take a polynomial and divide it by another polynomial. So this is not still a polynomial when you do this. It's not considered a polynomial anymore. But we can have an expression that's a compound of two different polynomials. So I'll give you an example of a rational inequality. So for example, something like this. Okay, this is a rational inequality, x plus 4 over x minus 2. X plus 4 is a polynomial, and x minus 2 is a polynomial. Now, the question is, how do you figure out where this rational expression is greater than 0? Well, we can use very similar techniques that we use to the quadratic functions. Particularly, we can find some critical points, and then we can look all around those critical points on the intervals and see, is this above the x-axis or it's below the x-axis? Is it positive on this interval or negative on this interval? The only difference is with the critical points for a rational inequality, we not only have to find where the expression is equal to 0, but also where it's undefined. So the two places we'll find critical points are, number one, where is the expression equal to 0? Well, if you think about a fraction, the only place that a fraction can be equal to 0, the only time it can be equal to 0 is if its numerator is equal to 0, right? If its denominator is equal to 0, it's undefined. It doesn't make any sense. So one of our sets of critical points is going to come from where the numerator is equal to 0. The other critical points are going to come from where the function, or where the expression, I should say, is undefined. So that would be where the denominator equals to 0. What x values makes this denominator equal to 0? And that will be one of our other critical values. So let's try to find these. So by critical points, I said first let's look where the numerator is equal to 0. So where x plus 4 is equal to 0. So that means one of my critical points will be x equals negative 4. And then I want to look at where the denominator equals to 0. So where does x minus 2 equal to 0? And I'll get x equals 2. These become my two critical values. So now I'll take these and I'll plug them into my chart. Now you'll notice that it's not as simple as it was with the quadratics, where a lot of times you could kind of picture it in your head and figure it out. With the rational inequalities, unless you've done a lot of work with them, with the rational expressions, it's not necessarily really easy to see them in your head. If you do a lot of them when you practice doing graphing some rational expressions, then it's not too bad. You start to pick up on some of the nuances, but still they can be a little difficult to picture. So we'll go with our chart and use that as our form of figuring this out. So I have two critical points, negative 4 and 2. That gives me 3 intervals to worry about. The first one is going to be x is less than negative 4. The next one will be x is in between negative 4 and 2. And then the last one will be where x is bigger than 2. So these are the ones that we're interested in figuring out. So from here, we'll do the same thing we did before. We'll pick some test points. X is less than negative 4. We'll pick we should be careful here. Negative 5, right, is less than negative 4. X is between negative 4 and 2. We can pick 0. If you can pick 0, that's always a good one to pick. X is greater than 2, maybe we'll just pick 3. And again, we're going to plug it into the expression and see if it's positive or is it negative. So this one's already factored, there's nothing really to do, so it's already in a good form. or I should say there's not really anything to factor, so we don't have to, this will work well for us. Unlike the quadratics where we wanted to write it in the factored form first. So I'm going to think about plugging in x equals 5. Well, negative 5 plus 4, plugging in x equals negative 5. Negative 5 plus 4 is a negative 1. And then negative 5 minus 2 is a negative 7. So I'll end up with a negative divided by a negative. Again, I don't care what that number is. I just care, is it positive or is it negative? Well, a negative divided by a negative is always positive. Okay, what about plugging in x equals 0? Well, 0 plus 4 is definitely positive, but 0 minus 2 is definitely negative. So a positive divided by a negative is always negative. X equals 3. 3 plus 4 is positive, and then 3 minus 2 is also positive. So a positive divided by a positive is positive as well. So we're going and looking for where is this expression bigger than 0. So this interval and this interval are the positive intervals. Those are the ones we're looking for. So that means that my answer to this will be wherever x is less than negative 4 or where x is greater than 2. You might see it written like this in the other notation. From negative infinity to negative 4, open parentheses because we're not including negative 4. And then from 2 to infinity, also open parentheses around the 2, open bracket, because we're not including the positive 2. Now let's try a couple more. So this one, 6x divided by x minus 4 is less than 5. Okay. Now this one's a little tricky. Before we can do anything, we have to subtract over the 5. Don't multiply both sides by x minus 4. It doesn't work in this situation. Because if you did that, you would end up with just a linear inequality, and you will not necessarily come out with the right answer. So don't fall into that trap. If this were an equation, that would be fine. But with the inequalities, it doesn't work that way. What I actually have to do is subtract over the 5 like this. And then what I have to do is actually combine these two fractions, make this have a denominator of x minus 4. So let's see, 6x over x minus 4 minus 5 times x minus 4 over x minus 4. I did this just to get the common denominators. Is all less than 0. So this will be 6x over x minus 4 minus 5x. And I'll tell you what we'll do. We'll go ahead and combine these to make it a little easier to look at. Since the equations have common denominators, we know the denominator will be the same. So this will be 6x. Negative 5 times x is minus x, and then negative 5 times 4 will be a positive 20. So be careful with your signs here. Okay. This is all going to be less than 0. So 6x minus 5x will be 1x, and then plus 20 all over x minus 4, less than 0. So these, where we have this extra constant hanging out, we have to do a little bit of work to it before we can actually solve it using our methods. So but from here, it's the same, right? We go through and we find our critical points where the numerator equals to 0. So set x plus 20 equal to 0, so we'll get x equals negative 20. And then also where the denominator equals to 0. So x minus 4 is equal to 0. So x is equal to 4. These are our two critical points. So these are the intervals around which we'll be testing. So negative 20 to 4. So that means I'll be testing from x is less than negative 20, and then x is between negative 20 and positive 4, and then x is greater than positive 4. These are my test intervals. And then I just should pick some test values. So x less than negative 20, they will pick negative 21. Between negative 20 and 4, if you can pick 0, it's always a good one to pick. X is bigger than 4, maybe I'll just pick 5. Okay, and then I'm going to plug these into this expression. Okay, so not the original one here, but the one that I have with the 0 on one side. So I'm going to plug it into x plus 20 over x minus 4 to see if I get positive or negative values. So again, don't worry about this, the fact that this is a big number. We're just going to plug it in to see if it's positive or negative. Negative 21 plus 20 is a negative number. Negative 21 minus 24 is a negative number. So everything on that interval should be positive. 0 plus 20 is positive. 0 minus 4 is negative. So this should be all negative on this interval. 5 plus 20 is positive, and then 5 minus 4 is positive also, so everything on this interval should be positive. Now be careful, don't get in the habit of going positive, negative, because every once in a while you run across one that doesn't do that, and it'll trip you up and you'll get the incorrect answer. So I go back and ask myself, I remember I'm looking at this one now, because this is the one that has a 0 in it. Where is this less than 0? Well, it's less than 0 on this interval. So I will say that between negative 20 and 4, that would be my solution set. Or in the other notation, interval notation, we'll say it's between negative 20 and 4 with open brackets because we're not including negative 20 and we're not including 4. All right, let's check out one more. X plus 4 over x minus 5 is greater than or equal to 10. Now again, I don't have a 0 on one side of the inequality, so I need to subtract over the 10 first. Don't try to multiply by x minus 5. It will only cause you problems. So I'll subtract over the 10, so I have that all of that minus 10 is greater than or equal to 0. Then I need to make this into a common denominator, so I should make it into a common denominator of x minus 5. So this will be minus 10 times x minus 5 over x minus 5 is greater than or equal to 0. So this will be x plus 4 minus 10x and then plus 50 all over x minus 5 is greater than 0. Then I just need to combine like terms up here. X minus 10x is negative 9x, and 4 plus 50 is plus 54, and all of that will be over x minus 5, and that will be greater than or equal to 0. And one last thing I'm going to do is I'm actually going to factor this top one. I'm going to pull out a negative 9. You'll see why at the end it makes things easier. So this will be negative 9 times positive x minus 6 is how I can factor the top. Like that. Okay. And I'm worried about where this is greater than or equal to 0. All right, so my critical points will come from where the top equals 0. The only time this will equal 0 in the top in the numerator is when x equals 6. And the only time the denominator will equal 0, that's where my other critical points come from, is when x equals 5. So these are my critical values here, 5 and 6. So let's try this. So I'm testing where x is below 5, where x is between 5 and 6, and then where x is greater than 6. All right, so let's pick some test values. X less than 5, I'll pick 0. If you can pick 0, it's a good one. Now this one, x between 5 and 6, you have to go to fractions. So I'm going to pick 5.5. And I'm actually just going to write it as a mixed fraction. I'm not going to write it as 11 halves. You'll see why in a second. X is greater than 6, I'll just pick 7. And I'm going to plug it into this factored version here. All right. Okay, so when I plug in x equals 0, negative 9 is always negative, so I have to include that here. But 0 minus 6 is also negative, and then all of that will be divided by 0 minus 5, which is also negative. So negative times negative on the top is positive, and then the bottom is negative. So a positive divided by a negative, that entire expression will be negative. So be careful when you have lots of positive and negatives floating around that you might want to simplify one step before you put in a definite answer. Okay, 5.5. Negative 9 will always be negative. But 5.5 minus 6, that will also be negative. That's why I did the 5.5, because then it's easy to say, oh, 5.5 is smaller than 6. 5.5 minus 6 must be negative. And then 5.5 minus 5, that must be positive 1/2. So this will be a positive over a positive, so a positive number. And then 7, negative 9 again is always negative. 7 minus 6 is positive. 7 minus 5 is positive. So this will be a negative over a positive or a negative number. So I'm interested in when this expression is greater than or equal to 0. So I want to look here at the positive one. So from the on the interval between 5 and 6, my solution is true. But I also am willing to take when this is equal to 0. Now be careful here. When is this equal to 0? Well, the entire expression is equal to 0 whenever the numerator is equal to 0. So whenever x equals 6, that will make that entire expression equal to 0, right? Because I'll have 0 divided by 1. Now, it's not equal to 0 whenever x is equal to 5. When x equals 5, this is undefined. So I cannot include the 5 here in my answer. Hopefully that makes sense. If you plug in x equals 6 and x equals 5, you'll see why only the x equals 6 works. So we only want to take that value. And then the way this will be written in interval notation is open bracket 5, because we're not including it, all the way up to close bracket 6, because we are including the 6 in that problem.